Hello viewers, so in this video we are going to be handling applications of differentiation and it's going to be video number 3. So this video is presented to you by Walgenbe Yusuf and you advise subscribe to the channel and share the video to your friends so that you can all benefit as a group. In this video we are going to be looking at rates of change as applied to applications of differentiation. So under this video, we are going to be seeing that example 1, a side of a tube increasing at a rate of 6 centimeters per second. Now always, just before we start this topic, always when you're interpreting such questions, each and every data that you are given in the question, you are supposed to summarize it down. So here, you are given the side to be increasing at a rate of 6 centimeters per second. That means that if at all the side is x, then that means that we have been given the x dt. Since the SI units are in terms of centimeters per second, so the x dt is going to be equal to 6 centimeters per second. And that's your first solution for you to note down the data that has been given in the question. Now the question is, find the rate of increase in the volume. Now the proceeding, if I tell you say this word when, you are supposed to bring in everything that is joined to this word later after you calculating for what is being required. So when the length of the side is 8 centimeters. So what is required, what we pick in the question is what they want. And here they want rate of increase of volume. So that means that they want dV, dt. So the best way to simplify these rates of change, first of all, you get the last variable, the variable that you have been given in the question, and it's what you multiply by as the last term. So we put here dx, and this is going to apply everywhere in each and every question that you are going to be doing. The reason why you do this is to enable you find or to enable you determine the value or the variable or the rate in which you are supposed to calculate or find out in the question or as you are solving the number. So first of all, you bring what you have been given in the question and you multiply it at the last. And here, if you look at these rates of change, we use a concept called chain rule. And according to chain rule, the variable which is up here is the same variable which is down here. So we are going to put here dx. And according to chain rule still, the value which is here is the value which is up here. So that means that here is going to be dv. So that means that what we need to find out first in the question is that we need to find out the derivative of volume in respect to x. I say that this is the master trick of mastering all this topic. So we are going to say that volume of a tube, since the tube all sides are equal, we label everything x. So volume of a tube is going to be given by x cubed. But since we want dv dx, we can differentiate. Since we only have one variable which is x. So differentiating in respect to x, you get 3x squared. But remember that in the question you are given your dx dt to be 6 centimeters per second. So you come to what they need. The question wanted dv dt, and we said that dv dt, according to the expansion we derived, is going to be got by dv dx times dx dt. And then you come and substitute. So the dv dx is the same as 3x squared, and then times dx dt, which was given as 6. So multiplying each other, you're going to get 18x squared. And substituting, now you after getting the variable that is required in the question, now you refer to the conditions that the question gave out. They are either going to use if or they are going to use when. So that's when you refer to those conditions after calculating for the variable that was required. So we come and we substitute, since they say that when the length of the side is 8 centimeters, we come and we substitute for the value of x in this expression. And then you are going to remain with 18 times 8 squared, which is going to give you 1152. But remember that this is volume in respect to time. So SI units must be centimeters cubed per second. You cannot get the actual mark without the standard SI units. So this was the final answer. Now let's see how this trick can be used to calculate other variables. this example, you are being told that the volume of a tube is increasing at a rate of 2 centimeters cubed per second. Like I told you, the first thing to do is to summarize out what they have been given. So dv dt, since the signs are in terms of centimeters cubed, that's going to be dv dt is going to be 2 centimeters cubed per second. And then they are telling you to find the rate of change of the side. That means that if at all one of the side of our tube is L, like I told you, you need to first find the expression that you are going to use. That means that here you are being given, you are being told to find the rate of change of the side. So it's going to be the L. The question requires you to find the L dt. And I will say that if you are going to start such questions in a simpler way, such questions by saying, for you to get the L dt, you get the variable that you have been given, and then you multiply it by the last term. So this is going to be times dv dt. And then after doing that, we use the concept of chain rule. Chain rule says that the variable which is here, we put it down here. So this is going to be dv. And then it also says that the value which is up here, we put it up here. And this is going to be the L. So that means that what you need to find out as you're solving this question is that you need to find out the expression of the L dv. But if you look at the L dv, the standard variable in the L dv is going to be volume, because it's the one which has a formula. Length does not have a formula. So you have to get dv dl, and then you find its reciprocal. So we are going to come here and say that by the dv dt that you have been given is according to this expression. You can either use this expression directly, or you can come and use this expression. So what we need to find is that we need to find a way of finding dv dl. And we are going to say that volume is given by L cubed. Then what about dv dl? So dv dl, we are going to differentiate volume in respect to L, and you are going to get 3L squared. Then you are going to come and substitute everything either in this expression or in this expression. And then you make the L dt the subject, just like here, and you're going to end up with 2 divided by 3L squared. Now after getting the variable that was required in the question, you go to the question and you refer, and you see whether you can see any concept like when, or if, and then you substitute for the given variable or the given standards that you're having in your differential equation. So here you are being told that find the rate of change of the side of the base if at all the length was 3 centimeters. So you come into this expression of the LDT and then you substitute for length as 3. So this is going to be 2 divided by 3 times 3 squared, which is going to be 2 divided by 3 times 9, and you are going to end up with your final answer to be 2 divided by 27. But you say that the A signs must be there for you to get the actualest mark. So since we are measuring the LDT, sorry, there was a misconcept here. Since we are measuring the LDT, length is in terms of centimeters and time is in terms of seconds. So that's why we write our SI units in terms of centimeters per second. So looking at example 3, they are saying that the area of a circle is increasing at a rate of 3 centimeters squared per second. So our first note, like we said, we first write out what the question is putting in front of us. So the A dt, we are calling it the A dt because they gave us area, because this is in terms of centimeters squared per second. So it's going to be the A dt to be equal to 3 centimeters squared per second. And then the question is requiring you to find the rate of change of the circumference. That means that they want dc, if at all circumference is going to be denoted by c. They want dc dt. So if you are to derive the expression, first of all, to see the variable that you are looking for, you get the expression that was given first and you put it last. So this is going to be times the A, this is going to be times the A divided by dt, since it was the given expression in the question. And then you use the formulas or use the concept of chain rule. What's up here goes down here. So this is going to be divided by the A. And also chain rule says that what's up here goes up here. So you put here DC. So that means that for you to get the CDT, as required in the question, you need to get the CDA multiplied by the ADT. So we need to find out finding the CDA. But if you look at circumference and area, both of them have independent formulas. So circumference is given by 2 pi r. And then area is also given by area of a circle is given by pi r squared. So you finding pi the CDA, and then you come and you either directly substitute in this expression for you to get the CDT, or you can follow this long formula that I gave here. Though it's more, this one is more detailed, but this one is direct. I've told you try to use both methods so that you can be good at it. So here, both of the circumference and area, they're having radius in common. So that means that for us to get the CDA, that's going to be another chain rule. So the CDA according to chain rule is going to be the C, the R, multiplied by the R, the A. So that means that you're supposed to get to differentiate circumference in respect to radius, you also differentiate area in respect to radius, and then you find the CDA. After finding the CDA, you come and substitute in this expression. Later, you come and proceed with the weighing condition. So let's look at what I presented here in details. So looking here, we are seeing that area is given by this expression, and for us to get the ADT, we are as it was given in the question, we get the ADR times the RDT. But I've told you that these are more advanced concepts. If you want to understand this topic properly, you are supposed to go with this concept, though I laid this out for you to be following up slowly as your knowledge is advancing. So the ADT is equal to the ADR times the RDT. We are saying that this because we can easily differentiate area in respect to R. And if at all we can differentiate area in respect to R, like we say the concept of chain rule, what's here comes there and what's here comes there. So we substitute for the ADR. The ADR differentiating area in respect to R, pi is a constant, you only differentiate R squared, and you're going to get 2 pi R. So that's why it's here. Then the RDT, but our ADT was given as 3. So substituting for it and you make the RDT subject, we are going to end up with 3 divided by 2 pi r. But remember that radius was given in the question, that when radius is equal to 2 centimeters. So we substitute for it so that we can get the final value of the RDT. But remember that that's not what was required. We also have, what was required was the CDT, which is the rate of change of the circumference of that circle. So circumference is given by this formula, then you find the CDT. For us to get the CDT as required in the question, we differentiate the circumference in respect to R, and then you multiply it with the RDT according to chain rule. What's up here must be the same as what's up down here, and what's here must be the same as what's here, and the last value here must be the same as the last value here. So that's the concept of the chain rule. But remember that we have already got our dRdt, and our dCdr is the same as 2 pi r. So we are going to say 2 pi r multiplied by the rdt, which was 3 divided by 4 pi. If you differentiate circumference in respect to radius, this radius is going to go away and then remain with 2 pi. That's why you are having here, or you are seeing here, 2 pi. So we come and conclude that by multiplying this one and this one, this 2 goes away, and here we remain with 2. So we shall have 3 divided by 2 pi, which is going to, and these 2 pi and pi are going to leave. So we remain with 6 divided by 4, which at the end of the day gives 1.5 centimeters per second. We are saying centimeters per second because circumference is measured in centimeters, and then per second because this is divided by time, or dt, to give us per second. So I hope that was clear. Now method 2, which is the direct one, is going to be this one. You try it out and you must have the same values of the answers. Try it out and you'll find that some of you, if not most of you, are going to be more conversant with this one other than this one. So try this out for higher practice or for advanced practice. If you get confused, try to reach me out. Now looking at another example, we are seeing that here a spherical balloon is inflated such that the rate at which its radius is increasing is going to be 0.5 centimeters per second. So the first thing we note is that we are going to note the RDT, which is given in the question, is going to be 0.5 centimeters per second. And then we are asked to find the rate at which, first of all, in part A, the volume is increasing at the instant when R is equal to 5 centimeters. So here they want rate of volume, or the rate of change of volume. So if you are to try to derive our expression by the first formula that I've told you, which is dV/dt, the question is in need of dV/dt. So you're going to get the last variable that you have been given. We have been given dr/dt, so we put it here, and we say that this is going to be dr/dt. Then after putting here dr/dt, we use the concept of chain rule. What's up here goes down here, so that you can see the variable that we need. So we are going to have here r, and then we put what's up here, we put it up here, and then we are going to have here dv. So it means that for this expression, we need to find dr. And if at all you look at the volume of a sphere, it's given in your mathematical logbooks. Always, if you're going to do applications of differentiation, open your mathematical logbooks. So volume of a sphere is given by 4 divided by 3 pi r cubed. And if at all we have to find dV/dr, because when you have one expression, dV/dr is going to be 4, because this 3 goes down here, and it's going to be cancelled away with the 3 in the denominator. So remain with 4 pi r squared. Now we come back to the question requirement and write that expression down. That for us to get dV/dt, we are going to get dV/dr, and then we multiply it with dr/dt. Now after writing that, we come back and say that dV/dt therefore is going to be equal to, we get 4 pi r squared times 0.5. You are supposed to show that step, that I messed it out. After that, it's like a half times 4 pi r squared. You are going to remain with 2 pi r squared. Now after getting what they want, the variable they want in the question, then I told you go and refer to the when or if that they use in the question. So here they said when r is equal to 5 centimeters, we substitute it here, and then remain with 2 pi into 5 squared, which is going to get you 2 times 25 to get you 50 pi centimeters squared per second. Now edit the units here, because we are getting volume. SI units must not be squared, they must be cubed. dV/dt, volume divided by time, is the same as centimeters cubed per second. Now handling the part B, we are being told that here the surface area is increasing at a rate of 8.5 centimeters. So they are asking us for the rate of surface area, and rate of surface area, we are going to take it as surface area, we are going to take it as area. So you are going to take it as dA/dt. So for us to get the dA/dt, first of all, in the question you are given the r/dt, is what you put last. And then use the concept of chain rule. So it's going to be times, since what's up here goes down here to become the r, and what you have here goes up here to get us dA. So it means that the expression that you're looking for is going to be dA/dr. So we come back and write that area is given by 4 pi r squared. So for us to get dA/dr, we are going to differentiate this. dA/dr, when you differentiate this, it's going to be 4 pi is a constant, so you need to differentiate r squared, and it's going to be 2r. So 2r times 4 gives you 8 pi r. So we are going to say, we are going to come to bring this expression here, and we say that for us to get the dA/dt is the same as the dA/dr times the r/dt. After that, we come and say that the dA/dt therefore is going to be equal to 8 pi r times the r/dt was given in the question as 0.5. So when you multiply this one and this one, in your calculator you're going to end up with 4 pi r. Then you refer, after getting the variable that they want, is when you can refer to the when part, or the when condition that is always given in the question. So here they say that when r is equal to 8.5 centimeters, so we substitute it in this expression, and then we get 4 pi multiplied by 8.5, and then you're going to end up with your final answer to be 34 pi centimeters squared per second. Now looking at example 4, we are saying that a hollow circular cone is held vertex downwards, and it's going to be beneath a tap which is leaking at a rate of 2 centimeters cubed per second. So first of all, we are going to first summarize all that, and we are going to say that since SI is in terms of centimeters cubed per second, that's going to be our dV dt. Now you are being told that find the rise of the water level. That means that what the question requires, rise of water level is going to be like the height. So the rate at which the water level is rising is what is being required in the question. So you are required to find the h dt when the level is 6 centimeters. Now we are going to come to that because they are using the when condition, and I've told you that when you see when condition, it comes later after you finding the variable that they want. So it's going to come after we finding the h dt. Now we are saying that here, given that the height of the cone is going to be 18 centimeters and this radius is going to be 12, just like sketched in this sketch. So what you do whenever you are given cones, you are either going to be given angles or you are going to be given dimensions, and those dimensions are just going to help you to use similarities. If you are using angles, you are going to be using tan theta. If you're using similarities, we also use tan, but you can also use small triangle and big triangle, just like you are coached in your O level. So according to similarities, the height of the water or depth of the water in that cone is going to be h, just like we have indicated here. Now the radius of this water in this cone at this height is going to be r. So you're going to find that you're going to end up with a similarity triangle. And this similarity triangle, we are going to have this dimension to be r and this dimension which is inside here from here to be h. And then the dimension which is completing, we are being told that it's going to be 18. And the radius of the radius up here is going to be 12. So when you're using similarities, majority of you at your schools use small triangle, small triangle, big triangle. So you get the opposite side of the small triangle divided by its adjacent side. So that's why you're seeing here r divided by h to be equal to the opposite side of the bigger triangle divided by its adjacent side. So it's going to be r divided by h being equal to 12 divided by 18. But if you divide 12 by 6, you're going to get 2, and if you divide 18 by 6, you're going to get 3. So you end up with r divided by h to be equal to 2 over 3. Now the reason why you're doing this is because if you look at this formula of volume of a, actually let's see the reason why we are making r to be in terms of h by first finding out the expression of what was being required. So in the question, what was being required was the h dt. So if I told you we are to get the h dt, how are we going to get it? So the question required the h dt being equal to what you're given in the question was dv dt, so we multiply the last. So you're going to be writing here dv dt. So what do we need to find? So we find the variable that we need to find, and you're going to put volume down here, just like I've been explaining before. So this is going to be dv, and then what's up here, we are going to put it here. So this is going to be dv dh. So it means that what you're looking for is going to be dv dh. But in here it's in terms of dhdv, but height is a dimension and volume has a formula which you wrote here. So it means that you need to differentiate in terms of h. But here remember that in this expression you're having r present there, and r is also a variable, and you cannot differentiate when two variables are present. That means that we need to convert r in terms of h. So that's why we use these similarities, and you're going to end up with your r, if you cross multiply with your r being equal to 2 over 3 h, and then volume, we come back and rewrite the expression of finding volume, and then we express everything in terms of h so that you can find dv dh. We cannot differentiate when both radius and height are present at the same time. You get it wrong. So substituting for r is going to be 2 over 3 h squared multiplied by h, and you're going to end up with your volume with this expression. So after squaring 2, you get 4, and after squaring 3, you get 9, and after squaring h, you get h squared. And then we sum everything up by multiplying 3 times 9 to get 27. 4 times 1, you're going to get 4, and then you're going to remain with this pi. H times h squared, you're going to end up with pi h cubed. Then you find the VDH, which was required for us to get DH/dt, and the VDH is going to be equal to, if 4 divided by 27 pi is going to be a constant, so you need to differentiate h cubed, and you're going to end up with 3h squared. Now the 3 is going to multiply the 4 and you get 12 divided by 27 pi h squared. After finding what is required, you come back to this expression and then you substitute it. Or you can use this expression. They are going to give you the same answer. And you're going to end up with your dH/dt to be equal to 54 divided by pi h squared. After getting what is required, you go back to your question and you find the value or the condition of when or if. So here they say that when the water level is 6 centimeters. So we have to apply that h is equal to 6 and we substitute for it in our formula. And you're going to end up with 54 divided by 432 pi. But here you simplify, you put everything in the calculator and you simplify, and you're going to end up with 1 divided by 8 pi centimeters per second. And you're saying centimeters per second because height is measured in terms of centimeters and time is measured in seconds. That's why the signs are in terms of centimeters per second. You cannot get the actualest mark without SI units in applications of differentiation. Looking at the next example, we are saying that an inverted right circular cone, which is having a vertical angle of 120 degrees Celsius, is collecting water from a tap which is steadily leaking at 18 pi centimeters cubed per minute. Now find part A, the depth of water after 12 minutes. Now here, every time you're given vertical angle means the whole of the angle circulating the cone, but we don't need the whole of the angle, we need half of it. So every time you're given vertical angle, you're supposed to have it. So when you have 120, you're going to get 60 because you only need one side of the cone or one side of the right circular cone, so that here we can have 60. And the reason why we give you these angles, just like I've said in the previous example, is that we need you to express either radius or height in terms of the other. So here we are going to have radius and here we are going to have height. So what we do is that we remember that this is angle, this is going to be 90 degrees. So R in this case is going to be our opposite and H is going to be our adjacent. So here we are having an angle of 60 degrees. So what we do is that we use the concept of tan theta, and tan 60 degrees here is the same as opposite, which is R divided by H. That means that by tan 60, according to standard triangle, which we covered in trigonometry, tan 60 is the same as root of 3. So root of 3 is the same as R divided by H. So we use this expression to express one in terms of the other, and we are simply by cross multiplying, and therefore R is going to be equal to root 3 of H. Now we come and write down, or we summarize some of what was given. So in the question you have seen that they gave us 18 pi centimeters cubed per minute. So write down 18 pi centimeters cubed per minute as the dVdt, which was required in the question. Now if you look at this question, if you look at part A, they want depth of water after a specified period of time. That means that they want the dH/dt. So we need to find out the expression that you are going to be using to calculate for dH/dt. But remember that we need to, we don't know any variable, or we don't know the volume in which these 12 minutes are existing. So you are going to say that 1 minute contains 18 pi centimeters cubed, and what about the 12 minutes is going to contain which volume? It contains x, we don't know. So cross multiplying, we are going to have x, which is a 12 centimeter, which is going to be the 12 centimeters cubed to see the volume we are going to be having, and it's going to be 12 times 18 pi to get 216 pi centimeters cubed. Now this is the volume which is present in 12 minutes. So we can go ahead and we find our dH/dt, which is present in this volume. So we're going to be saying that volume of a cone is given by a third pi r squared, but we have already expressed r in terms of h. So we come and we substitute for that, and you're going to have this expression where there is r, you substitute with the expression that you have got from similarities or from using angle theorem. So after that, when you square root 3, you get 3. When you square h, you get h squared, and then h squared times h, you are going to get h cubed. So the 3 that comes out of this bracket is going to cancel with the 3 present in the denominator, and you end up with your volume to be given by pi h cubed. But here, the reason why we are getting volume to be pi h cubed, we don't know, they didn't give us anything like when condition in this term. That means that we are supposed to get the when condition ourselves. So we are going to get the expression of, or the final answer of volume that we got, and we equate it to this expression. After that, we are supposed to find the value of h. So pi and pi are going to go away, and we are going to end up with finding cube root on both sides of 216 and h cubed, and you're going to end up with the value of h to be 6 centimeters. Now you come back, now this is your when condition. We have created our when condition, but we are not interested in this. We are interested in finding the h dt. So just a simple outwork, we are going to first derive the expression that is going to help us find the h dt. So the h dt is going to be equal to, what we are given, the question was dv dt. So since we are given dv dt, so the variable we are looking for is going to be here. We put here this dv, and up we are going to put here this dh. So it means that we are looking for dv dh, and after we find this reciprocal. So since we already have the expression of volume to be equal to pi h cubed, we can find dv dh by differentiating with respect to height. So doing so, we are going to have dv dh to be equal to 3 pi h squared. Then we come back and we find our dh dt. I said that you can either use this expression and then you substitute and you divide, or you can use this one directly. That helps you to derive what you are finding. And you're going to end up with your dh dt to be 18 divided by 3h squared. And then remember that we created our when condition that h is equal to 6 centimeters. So we come and substitute for the value of height and remain with 18 divided by 3 times 6 squared, which is going to give you 1 over 6 centimeters per minute. Remember that the signs that were given were in terms of per minute. Don't forget that, and you substitute with seconds. Actually, some mark comes on the SI units. That's with applications of differentiation. Now looking at the next example, we are saying that an inverted cone with a vertical angle of 60 degrees, just like I said, whenever you're given vertical angles, you divide it by 2, so that you can get one right-angled triangle within the cone. And it's collecting water, and you are given dv dt. So dv dt is equal to 2 centimeters cubed per second. Now if they told you if the height of the water is 10 centimeters, now since they use this condition of if, which I say that is the same as when, that means that you are going to bring in the if situation or the when condition later after finding what they want. So here they want us to find the rate at which the depth is decreasing at that instant. So they want the rate of change of depth, which is represented by dh dt. Now trying to derive our expression, you are going to say that dh dt, which is the required expression in our question, dh dt is going to be equal to, the given expression was dv dt, so we write it last. And then we use the concept of chain rule. What's up here comes down here. So this is going to be dv. And what's up here comes up here, and you're having dh. So that means that you need to find dv dh. But before, if you look at the formula of volume, finding volume of a cone, it's having both radius and height. So we need to express one in terms of the other. So that's why they give us angles. So use the concept of tan. So tan 30 degrees here is going to be equal to opposite, which is radius, divided by your base, which is height. So you're going to, but tan 30, according to standard triangle, is the same as 1 out of root 3. Now, if you're not well conversant with the standard triangle, this tan 30 is present in your logbook, and you are always availed with them, or you are allowed to enter the examination room with them. So make sure that you get conversant with special angle triangles or special angles. So this is going to be 1 divided by root 3 being equal to r divided by h, and expressing one in terms of the other, we are going to have your r being equal to, if you are to make r the subject here, r is going to be equal to h divided by root 3, and we are making r the subject because we want to find dv dh. And the only way to find dvdh, we need to express the volume in terms of h only. So we make r the subject so that you can substitute for it in the formula of volume of the cone. So substituting for r, we are going to end up with this expression. And multiplying everything, you are going to end up with 1/9 pi h cubed. So you can go ahead and define that dvdh. So dvdh is going to be the 3 divides this 9, and you end up with 1/3 pi h squared. Then you come back to this expression and say that dh dt is equal to dh dv, which is the reciprocal of what you have got, times dv dt, which was given in the question. And if you do so, you are going to end up with your final answer to be in this format. And then you come back to the when condition after finding the variable that they wanted you to find in the question. So here they say that if, which is the same as when. If the height, or when the height of water is 10 centimeters, so we substitute for the height by saying that when h is equal to 10, dh dt is going to be 0.6 divided by pi 10 squared, which is going to end up with 6 divided by 1000 pi centimeters per second as your final answer. I say that SI units must be written properly. Since we have already seen a lot of examples, let's go through this UNEB question quickly. So here I say that a hemispherical bowl of radius 8 centimeters is initially full of water, and then the water runs out through a small hole at the bottom of the bowl, which is at a constant rate in 24 seconds. Given that when the depth of water is 8 centimeters, its volume is going to be represented by this expression. Show that the depth of water at that instant is going to be represented by this expression. And then find how long it will take for the depth of water to be a third 8 centimeters, and the rate at which the depth is increasing at that instant. So the rate at which the depth is increasing at that instant, that's the same as dh dt. So we're going to first start by sketching. Now notice that this is a hemisphere. If it's full of water, this is the same as radius for the hemisphere, and also this is the same as radius. So if the hemisphere is full of water, x is equal to a. So first of all, you are going to write the volume of the expression they told us, they given us in the question for finding volume of a hemisphere. And then we are going to say that when it's full of water, x is going to be equal to a. Just like I've explained, x is going to be the same as this. Just like we are looking at maximum and minimum. And then proceeding, we are going to be saying that here, therefore, volume is going to be equal to a third pi a. Since x is equal to a, we substitute all the values of x with a, and you end up with this expression that volume is equal to 2/3 pi a cubed. But then they told us that it empties all in 24 seconds, and use these 24 seconds so that you can get volume per centimeters. Since we're having here volume, to get volume per centimeters cubed, you get this volume, and then we divide it by the seconds that were given. Because they say that this volume, if at all the hemisphere, the full hemisphere empties in 24 seconds, then what about in second? Because we need to get per second. Per second means that you need to get volume that is emptied in 1 second, and that's going to be your dv dt. So 24 seconds contain this volume. Then what about 1 second? We don't know. So we cross multiply, and then we divide through by 24, and then you end up with 2 divided by 72 pi h cubed centimeters squared per second. And then you can divide by 2 so that you can remain with this expression, which is your final value or final expression of dv dt. And this one always remain constant. So we come back and say that when x is not equal to a, that's when the hemisphere is half filled, and they want when the water is decreasing. So that means that the hemisphere is going to be half filled, and therefore x cannot be equal to a. They will be varying. So we shall be saying that the expression of volume, we'll write it again, is going to be this, and you are going to be saying that dx dt, which is required. Remember that in the question they wanted to find the rate of decrease of the depth, and you can use it the other way that I was teaching you, or you can find it by this way. Since we have already got dv dt, and we have also got dv dx. So when x is not equal to a, you find dv dt, which you have already got as pi a cubed divided by 36, and then dv dx, you just differentiate this expression without considering the a, because we assume that a is going to be constant. So differentiating that, you're going to end up with this expression, and then you make the x dt the subject, which was the required expression in the question. After that, you make sure that everything is linear by taking the denominator up and powering it to -1, and your value of the x dt is going to be that. So proceeding with the question, when height is equal to a third of a, we are going to substitute that into our expression. And we're going to be saying that, okay, so volume is going to be equal to a third pi, a third a. Wherever there is x, you substitute a third a. And because x was our value up, going upwards, so when it's a third of a, you substitute it with that. And then simplifying, you simplify further and you end up with 8 pi h cubed divided by 81. Now you're saying that volume of water in the bowl is going to be this. And also volume of water emptied is going to be the difference between the first volume that we got here and the volume when it is a third of a, so that we can find the volume of water emptied or removed. So getting this, you just find the LCM is going to be 81, and dividing 81 by this and multiplying it by the numerator and then subtracting, you're going to end up with 46 pi a cubed. And you're going to be saying that therefore, but you already got our dvdt, which was here, dvdt to be equal to pi a cubed divided by 36. But this dvdt was present in 1 second, but we don't know the time required to empty this volume that we have got. So we are going to say that x seconds can empty this volume. And then cross multiplying and then dividing, you're going to end up with your value of x to be 20.4445 centimeters as required in the question. This brings us to the end of applications of differentiation under rates of change. So the other differentiation parts that you are going to be looking at are going to be techniques of differentiation, and you are going to start with parametrics together with use of natural logarithm and exponential functions. So make sure that you subscribe to the channel, share the video to your friends, and share the video to your group mates, so that you can all discuss this work as a group. If you find any inconvenience, try to make a group and you discuss these numbers with any of your friends, and then reach me out in case you are finding any trouble. So success for those of you having papers.